In this lesson, we will examine the function of the components that make up the nose landing gear. In this lesson, we will examine the function of the components that make up the nose landing gear. We will look at the operation of the nose wheel steering system, and then we will go on to discuss the problem of nose wheel shimmy. The nose undercarriage is usually a lighter structure than the main unit, since it carries less weight and is usually subject only to direct compression loads. It does, however, carry the attachment for the towing equipment, and so must withstand the shear loads associated with towing operations. Nose gear design is complicated by several requirements. It will normally have a steering system fitted, or it will have the ability to caster. But it must be able to self-center prior to gear retraction. Castering is explained later in the lesson. The nose gear also needs to have a method of countering shimmy. The diagram shows a typical large transport aircraft nose gear. As with the main gear, it has a drag brace assembly to give fore and aft support, and side struts for lateral support. The torque links transmit the steering actuator movements to the axle. We will look at steering, but later in this lesson. Castering is the ability of the nose wheel to turn to either side in response to the results of differential braking, or thrust or aerodynamic forces on the rudder, and to return back to its central position when the forces are removed. To enable an aircraft without a nose wheel steering system to be maneuvered about the airfield, the nose wheel must caster freely. Automatic self-centering of the nose wheel is essential prior to landing gear retraction. If the nose gear is not in a central position, that is to say, with the wheels pointing in a fore and aft direction, prior to its retraction, the restricted space available for its stowage will not be sufficient, and severe damage may be caused to the aircraft structure as the hydraulic system forces the gear upwards. Centering is achieved by either a cam system, which centers the nose wheel as the oleopneumatic strut extends on takeoff, or by hydraulic power being applied to both the nose wheel steering actuators when the landing gear is selected up. The graphic here demonstrates how it may be done using a cam system. A method of steering is required to enable the pilot to maneuver the aircraft safely on the ground. Early methods involve the use of differential braking in conjunction with a castering nose or tail wheel. This method is used on modern aircraft in the event of nose wheel steering system failure. Light aircraft use a simple steering system, where the nose wheel is mechanically linked to the rudder pedals. Most large commercial aircraft use hydraulically powered steering systems, allowing their engines to be set at the minimum thrust for taxiing, thereby saving fuel. This method of steering is more accurate. It also reduces tire and brake wear and noise pollution. A hydraulically powered system may include a cockpit steering wheel or tiller, a control valve, steering cylinders to hold the nose gear, and a mechanical feedback device to hold the nose wheel at the selected angle. Steering is controlled, depending on the type of aircraft, by either the steering wheel or tiller, or by the operation of the rudder pedals. On some aircraft, the rudder pedals have a limited steering capability, allowing the pilot to keep the aircraft straight during takeoff, whilst normal ground maneuvering is achieved using the steering tiller. In hydraulically controlled nose wheel steering systems, the operating pressure is derived from the aircraft hydraulic system. In the system shown here, hydraulic pressure is supplied from the same line that lowers the landing gear, so steering is only available when the gear is selected down. In some aircraft, a limited emergency supply may be provided by a hydraulic accumulator. There are two steering actuators which steer the nose gear. The restrictors in the pipelines between the steering actuators provide dampening for the steering operation and help to prevent nose wheel shimmy. As we mentioned, shimmy will be explained later on. The steering wheel or tiller is mechanically linked to the steering control valve. A follow-up linkage from the nose undercarriage gradually resets the control valve as the nose wheel turns. When the tiller is turned, it moves the control valve away from its central position. This ports fluid to the steering actuators, causing the nose gear to turn. You will notice that the jacks change direction as they pass through the center point of the strut. This is achieved by fluid transfer ports machined into the actuator cases. When the nose wheel reaches the selected angle, the follow-up linkage will centralize the control valve, shutting off fluid to the actuators. Fitted between the two sides of the steering actuators, it is normally held closed by hydraulic pressure. The purpose of the safety bypass valve is to allow the nose wheel to caster if there is a hydraulic failure. If the hydraulic system should fail, the spring will push open the valve, allowing fluid to flow freely between the actuators, thus allowing the nose wheel to caster. Some systems allow a limited amount of manual steering in this circumstance via the follow-up linkage. Some systems have the facility bypass the steering system during towing operations. In the system shown here, there is a bypass lever, which, when operated, opens a steering bypass valve. When the lever is operated by a ground engineer at the nose gear location, it opens the valve, allowing fluid to flow freely between the steering actuators. A bypass pin, with a flag attached, is fitted to hold the lever in the valve open position. The tractor can now tow the aircraft and turn the nose wheel as necessary. It is important that the bypass pin is removed before you commence taxiing. It is normally held aloft by the dispatching ground engineer as he moves clear of the aircraft, confirming to the pilot that it has been removed. Large aircraft with multi-wheel main gears have a problem with the main gears sliding sideways in turns. This is known as scrubbing and can quickly damage tyres. This is particularly a problem for body gear, as they are near the centre of the turn. To help improve the turning circle and reduce tyre scrubbing, some aircraft have steerable body gear, which operates automatically in the opposite direction to the nose gear when the nose gear steering is operated. To minimize tyre scrubbing, it is recommended that the aircraft be maneuvered on the ground using the largest turning circle possible. Tight turns should be avoided if at all possible, and the aircraft should be moved in a straight line for a short distance before stopping, in order to remove the twisting stresses from the main gear tyres and legs. Due to the flexibility of tyre sidewalls, an unstable, rapid, sinusoidal oscillation or vibration, known as shimmy, can be induced into the nose undercarriage. Worn or broken torque links, wear in the wheel bearings, and uneven tyre pressures can all increase the tendency to shimmy. Excessive shimmy, especially at high speeds, can set up vibrations throughout the aircraft and can be dangerous. The best ways to keep shimmy to a minimum are to maintain the nose gear correctly, replacing worn-out parts, and by maintaining correct tyre pressures. However, many nose wheels are still prone to shimmy, and there are a number of methods used to try and reduce its effects. As previously mentioned, hydraulic damping, in the form of restrictors, can be provided across the steering jack pistons or piston. A hydraulic or spring shimmy damper can be attached between the upper and lower oleopneumatic strut cylinders. Many larger aircraft use double nose wheels to help reduce shimmy, while twin contact tyres have been found to be effective in minimizing tailwheel shimmy. That is the end of the lesson. You should now know that an aircraft with a free castering nose wheel can be maneuvered on the ground using differential braking. You have seen that the nose wheel can be steered both by using a tiller or the rudder pedals. You should now understand the term shimmy, and that it can be minimized by good maintenance, by fitting restrictors in the hydraulic nose wheel steering system, and by fitting a shimmy damper, or by fitting twin nose wheels or twin contact wheels.